Hello mathematicians, and welcome to Mathematics Extension 1 at St Mary's. In our preliminary course, the first topic that we have a look at is methods in algebra. And this little blurb, a new way of mastering mathematics, the reason that that's there is because I want you to, over time, think about how you do maths. We're going to shift the emphasis from memorization, although some things need to be memorized, they need to be made automatic, towards understanding. And of course, the more you understand, the less you need to memorize. The other big difference is problem solving. We need to be able to attack a range of different problems and use our understanding to be able to deal with those. Algebra in particular has to be a tool that you both understand and that you can use automatically. It's the building block for nearly every topic right through maths, and if you struggle with algebra, you're going to struggle with the rest of the course. There's no easy way to put it. So you need to know the terminology, you need to have a good understanding, not just rely on memorized techniques, and you need to talk to me. If you don't get it in the sense of understanding it, then ask about it. We begin with the concept of an algebraic expression, which is simply a combination of terms which may have numbers and variables, or you may have called them pronumerals. So this is a term. It's a discrete combination of numbers and variables. In general, terms are separated by an operation sign. So 6a is a term, 3b is a term which is being added to 6a, c is a term, this is a term, that's a term, the numerator is a term, and the denominator is a term. Simplifying an algebraic expression just means rearranging it. It doesn't mean solving it. Solving it would imply that somewhere there's an equals in the question. We may introduce equal signs later on, but it has to be in the question if you're going to solve it. So if we think about this, and you would have first seen this way back in Year 7, when terms are being added or subtracted, they can be simplified by combining like terms. So if we have an a plus an a, then it equals, so we're introducing that equal sign to say it's equivalent to, it equals 2a. You know that this is 5a, this is a, this is negative a. This one here, we can't do anything with, because although they're the same pronumeral, the fact that this is being squared makes it a different quantity. So an a is an entirely different thing to an a squared, just as, for example, a 3 is a different thing to a 3 squared. It's a 9. And likewise, an a plus a b, we can't do anything with. I'm sure you're also comfortable with the fact that when terms are multiplied, we multiply the numbers, we certainly know how to do that, and we multiply the variables. Now if the variables are different, there's nothing we can do. So an a times a b is just an ab. It's no different, we've just left out the multiplication sign. A 3a times a 2b is a 6ab. So we can multiply the numbers, but again, nothing we can do with the variables. However, when the variables are the same, then we can use powers. We make use of the fact, again, that you probably learned in around about Year 8, that if we have the same base, so the same variable just here, and they're being multiplied, then we add the indices. So a 3a times a 2a is a 6a. You know that a times a is a squared, but the reason is it's an a to the 1 plus 1. So our next one is 6a to the 9. Next one after that, we've got negative 6a to the 9. And the last one, just being careful of the two negative signs, that's going to give us a positive 6a to the 9. When terms are divided, we end up dividing or cancelling. Cancelling is often a quicker way of doing it, thinking about it, especially when it's not nice even division. And to divide, if we have same base, then you know that you learnt the rule in Year 8 that you subtract the indices. So a to the m divided by a to the m, which is written like this also, is a to the m minus n. So let's have a quick look at these ones. So a divided by b, nothing we can do. 4a divided by 2, I tend to write them always as fractions, so then the cancelling, which is just division, takes place. So the 2 goes into the 4 twice. Remember, this is not gone, it's not a 0, it's really just a 1. So our final answer there is 2a over 1, and we don't write the 1 on the bottom. 4a divided by 2a, again, it might seem like overkill to write this down, but it's amazing how many times you'll make a silly mistake. So the a's cancel, because we're saying a to the 1 divided by a to the 1, which is a to the 0. A to the 0 is 1. There are no a's anymore. 2 goes into 4 twice. Our next one, we've got 7 and a to the 5th. I'm just being a bit lazy now. And because the numbers also go in nicely. Negative 8 divided by 2 is negative 4. And a to the 3 minus 2 is a to the 1. And this one here, the two negatives mean 8 divided by 2 is 4. And again, a to the 1. Next example, we've got a power raised to a power. Again, you know the power rule, which is that we multiply the indices. So a to the m raised to the n, or vice versa. The answer is a to the m times n. It's also a good reminder about how brackets operate. So in this example here, all of that is in brackets, so all of it gets squared. So that means that the 2 gets squared to become 4, a to the 3, or a cubed, gets squared to become a to the 6th. Down here we have any number or pronumeral raised to the 0 power is equal to 1. We just have a few more examples here. I'm not going to run through all of them unless you're having problems, and then please talk to me about it. But simplifying here, because we're just adding and subtracting, that's the only operation in here, we know it's gathering like terms. So if we look at, for example, b, it has two sorts of terms in it, a squared, one's involving a squareds and one's involving a. So the a squareds are the only ones we can combine. So if I take the term and the sign in front of it, for the a squareds, I've got 2a squared minus 5a squared, so that's minus 3a squared. And for the a's, I've got plus 7a minus 3a, so I've got plus 4a. And it's just that process. Identify the terms, the sign or the operation that's to the left of it belongs to that term, and then do it, basically. Next example are multiplications. Again, I might just do a couple of these, so say E and F. So for E, we multiply the numbers, so that'll be negative 8. It's the same pronumeral, so we add the indices. So that'll be 8x to the 5th. The one down below, we multiply the numbers, so that will be negative 6. I've got two types of terms, so for the same base, which is p, I've got p to the 2 times p to the 1, so that's p to the 3, and q to the 1 times q to the 3, so that's q to the 4. Now for our division here, let's try d and f. So if I take d, that's equal to, and I'll write it as a quotient to start with, a to the x cubed negative a squared x cubed, and then I can see the x cubed cancels. So there are no x's in my final answer. Be careful with your writing, hopefully it's better than mine. So I've got a positive divided by a negative, so I'll have a negative answer. I can write that out the front, up the top, down the bottom, it makes no difference. And a to the 6th divided by a squared, we know that's a to the 4th by our rule, or we can think of it as these two a's cancel out with two of those to leave 4 of them. So minus a to the 4th is our answer to that one. This one here takes longer to write it down than to do it. So negative 50 a squared b to the 5th c to the 8. There's always a chance that you will miscopy here, but the thing is that in the HSC, if you miscopy at this stage, no problem, as long as you do yours correctly. If you launch straight into a line of working and in your head you've miscopied and you get it wrong, bad luck. You lose the whole lot of your marks. So what have we got? Numbers. So the two negatives become positive if you like. The 10 goes into the 55 times. This A will go out with one of these. These 3 B's will go out to leave 2 of those. And these 2 C's will go out to leave 6 of those. So altogether, we've got a 1 on the bottom because everything is cancelled out. And we've got 5ab squared c to the 6th up the top. You could now start working through questions 12 to 18a in 1a. Don't forget to check your answers, set them out logically. I haven't got too much patience with people who make mistakes because they don't set their work out. That's just sloppy thinking. So we need the question, and then every time you write something down, there's got to be a reason. So be very careful with the equal signs. Remember, they mean that this line is the same as this line, and there has to be a reason that's been the case.